Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over another example of balancing a redox reaction. But in this case, instead of balancing it in an acidic solution, we're going to balance it in a basic solution. So we're going to use the same method, same half reaction method as before. It's pretty much going to be the same steps as we did with an acid, but this time we're going to use hydroxide to neutralize the H plus. Okay, let's get started. So first step is to identify the oxidation states of the elements. So I here we're going to have a negative 1 there. We have oxygen has a -2 oxidation state. We have 4 of them, so that's going to be a -8 for oxygen. So this is going to be 2 negative for oxygen. However, we got 4 of them. That's going to be -8. We have an overall charge of -1. So the total for the manganese should be such that it's going to be a positive charge such that we get an overall -1. So that's going to have to be a +7. So this is going to be +7 oxidation state for the manganese. Then we go over here. Iodine in its standard state is going to be 0. So this is going to be 0 oxidation state, 0 charge. So that's going to be 0. And then we have, again, oxygen here is going to be -2 oxidation state. And since we have 2 of them, that's going to be a total of a -4 oxidation state. The overall substance here is neutral. So that means the positive oxidation state on manganese has to balance out the oxygen. So that's going to be a +4 oxidation state. So, okay. So now that we have the oxidation states, we just figure out our reduction and oxidation half reactions. And remember, oil rig or Leo Ger. So oil rig, oil, oxidation is loss of electrons. So what lost electrons? So losing electrons means you become more positive, less negative, more positive. So what became more positive? So we have a negative going to 0. That becomes more positive, less negative. So iodine here got oxidized. Okay, so this is going to be oxidation. So iodine aqueous goes to iodine aqueous. Okay, so that's oxidation. And then so now rig is reduction is gain. Reduction is gain of electrons. So when you're gaining electrons, you're becoming more negative, less positive. So more negative. Which one is becoming more negative or less positive? So we have +7, +4. The oxygen is not changing. So the manganese is what gets reduced. So manganese is getting reduced. So that's going to be our reduction half reaction. So we're going to have MnO4- aqueous going to MnO4 solid. Okay, now we have our 2 half reactions. Now we got to balance all of them, both of them together. So the first thing you want to do is balance the atoms, balance the mass. Okay, so here I have 2 iodine atoms on this side. I only have 1. So we're going to have to put a 2. Okay, so now the number of atoms is balanced for this one. For here, we've got oxygen and oxygen, and we're going to have to balance the oxygens, and we're going to have to do that the same way we did before with the acid in acid solution. So we have 1 manganese on each side. This is actually wrong. That should be a 2. Okay, so here we have 4 oxygens. Here we have 2 oxygens. So we need 2 oxygen on this side. We're going to use water to add oxygens again. So we're going to add 2 waters, 2 H2O, and that's going to be liquid. Okay, the next thing we're going to do, since now we have our oxygen balance, so 4 on this side, 4 here. Now we have hydrogen on this side. We're going to have to add H plus again. So we have 4 here, and we're going to add H plus, 4H plus. Okay, so far so good. So this is so far just like acid solution, but here's where it's going to be different. Now you have to add hydroxide. Remember, we're in a basic solution, so we're going to add hydroxide to neutralize the H plus, neutralize the acid. Okay, if we add hydroxide to one side of the equation, we need to add the same number to the other side of the equation to balance the number of oxygens and hydrogens. So, so right now it's balanced. And we want to keep that balance. So if we're adding more on one side, then we got to add the same number on the other side. So here, we're going to add plus OH minus. So that's going to be 4 OH minus to neutralize the 4H plus. And then we got to add 4 OH minus on that side. Okay. So that is so far so good. All right, sorry about that. All right, so now that everything's balanced, here we have our 4 hydroxide. Here we have 4 hydroxide, 4 hydrogen, hydrogen ion. So these are going to just make 4 H2O. Okay, so now if I rewrite this, I would have 4H2O plus MnO4 minus aqueous goes to MnO2, 2 water, and 4 hydroxide. I have 4 water on this side. I have 2 here. So these 2 waters would cancel out with 2 of these, leaving 2 there. Okay, so now if I rewrite this, we'll get 2 H2O plus MnO4 minus aqueous. This is liquid, forgot that. And this goes to MnO2 solid plus 4OH minus. And so here it is now balanced. So we have 6 oxygen on this side. We have 2 and 4 is 6. We have 1 manganese, 1 manganese. We have 4 hydrogen, and we have 4 hydrogen. Okay, so this is now balanced. This is balanced. So we've balanced the number of atoms so far. We're obeying the law of the conservation of mass. So now we have to balance charge. This is where the electrons come in now. So I have 0 on this side. I have 2 minus on this side. So I'm going to have to balance it out by adding plus 2 negative electrons on this side. So now I have 2 negative, 2 negative. Okay, what about over here? I have here, this is neutral. This I have is 1. I have 1 negative here. I have neutral, and this is 4 negatives here. So I have 1 negative, 4 negatives. So I'm going to have to add 3 negatives on this side to balance it out. So that's going to be plus 3 negative electrons. Okay, so now both of them are balanced with charge. And so now, before I add these together, I have to make sure the number of electrons are equal on both sides. So I have 3 on this side, 2 on this side. So if I had 6 on both sides, then that would cancel out the electrons. So I'm going to multiply everything here by 3. So that's going to give me 6I minus aqueous goes to 6, oops, that's going to be 3, I2 because I'm multiplying everything by 3, and then plus 6 negative electrons, 6 negative electrons, and then over here I'm going to multiply everything here by 2, so then it's going to be 4 H2O liquid 2 times plus 2 MnO4 minus aqueous goes to 2 MnO2 solid times, and then 2 times 4 is 8 hydroxide aqueous, and then I have, I forgot my electrons on this side, so this will be plus 6 electrons on the reactant side. All right, so now I'm ready to add these two half reactions back together. When I do, I have 6 electrons on the product side here. I have 6 electrons on the reactant side here. Those are going to cancel out. So I add these together. These are going to cancel out, so I'm not going to include them. And then everything else I include. So here, I'm going to include my reactants first. So I have, let's see here, I'm going to cut this here. Mark that off. So on the bottom, so I have 6 iodide aqueous, that's from here, and then I have my reactants here, plus 4 H2O liquid, plus 2 MnO4 minus aqueous, and then those are my reactants. All I have left are product. So then I have here the product, 3 I2 aqueous. So I'm done with the products here. Now the products over here. So 2 plus 2 MnO2 solid plus 8 OH minus aqueous. So this is your balanced equation, your balanced redox reaction in basic solution. So I hope this was helpful. If you enjoyed this video, if you enjoy my videos, please like, share, subscribe, hit the notification bell, make a comment in the comment section, and thanks for joining me. I'll see you next time.